Last spring, many people were caught off guard by the need to immediately start teaching science through distance learning. Somehow, you had to go from teaching hands-on lessons in the classroom to teaching the same science to kids that were now at home, overnight. Educators that wanted to teach more science found themselves asking questions. At Carolina Curriculum, we wanted to do something to help you keep teaching science this year. Over the next 20 minutes, to help answer these questions, Cory Ort, Carolina Curriculum's National Science Consultant, is going to share 8 strategies to adapt science for distance learning from Next Gen Science. Additionally, he'll introduce the new Building Blocks of Science 3D at Home, a digital resource that supports the distance teaching and learning of science from kindergarten to grade 5. Cory is going to model an actual lesson from Building Blocks of Science 3D using an at-home lesson plan from BBS 3D at Home. Using the adapted lesson plan, he will lead you through an investigation that integrates phenomena discussions, teacher demonstration videos, and simulations that mimic the hands-on investigations your students would normally do if they were in the classroom. Are you ready to keep teaching science? Stay tuned.
To demonstrate the 8 strategies we discussed in Part 1, we're going to model Lesson 2, Investigation A, from Building Blocks of Science 3D, Forces and its Interactions. We're going to follow the same 5-step lesson planner from Building Blocks of Science at Home. First thing we need to accomplish is getting logged into Carolina Science Online. Okay, here we are at carolinascienceonline.com. We're ready to log in. We go up to the top right corner and click Student Login. And for the purpose of this workshop, everyone has the same user ID, which is Workshop. No capital letters, nothing like that, just the word Workshop. And the password is the oh so tricky password of password. No capitals, anything like that. It's just Workshop, no capitals for user ID, and password is your password. When you've typed that in, click Login. And when you log in, you will see your assignment for Lesson 2, Investigation A. Now that we can log in, let's get started on modeling this investigation. Class, I have a phenomenon for you guys to think about. How many of us have ever been to an amusement park or a park where there's a couple of slides side by side and you've played the game to see who can get to the bottom of the slide the fastest? Raise your hand in the chat room if you've seen that before or done that. Almost all of you guys. That's exactly right. Well, imagine, let's say we had 4 slides. The first slide was freshly cleaned and oiled and smooth. And whoever got to go down that slide, what do you think would happen? Then a second slide where a student got to sit on the mat and slide down the slide. The mat would be smooth. Third, imagine if you just sat on your bottom and slid down the third slide. And then on that fourth slide, what if someone was on the top and shoved you down? Who do you think would get to the bottom first? Why? Take a second and write down your ideas and what this makes you think about in your science notebook, and then place a few comments in the chat. This is going to be the phenomenon we're going to be examining over the next 3 investigations. So let's go ahead and get started with the investigation. Last unit we talked about balanced and unbalanced forces. We also discussed types of forces. Put in the chat right now some of the forces we discussed in Lesson 1. That's right, the force of gravity, that force that pulls you down when you drop something or you jump off of a swing. Us, that's exactly right. We are capable of exerting forces on things. We saw that in the last investigation where we balanced forces by using our finger to push down or pull up on our lever. We're capable of exerting forces. The force of friction is one we discussed. That's exactly right. In this lesson, we're going to examine the force of friction really closely. We're going to experiment with it. These are all forces. So imagine if I took my car right here and I put it on my hand. Could you guys describe the forces that are pushing or pulling on the car right now? Put your answers in your chat. That's right. The force of gravity is pulling down on it and the force of my hand is pushing up on it. Now, I'm going to take the car and I'm going to throw it up in the air. When it's right in the middle, describe what forces are on it when I throw it up. Write that down in your science notebook. Imagine what would happen if I took my car and put it on my desk and I pushed it forward. What happens? I push it forward and it rolls and it slows to a stop. Why? Is this an example of balanced forces, do you think, or unbalanced forces? That's what we're going to start investigating. The influence of balanced and unbalanced forces. Now, before we get started, I need you guys to log in to your Carolina Science Online accounts and pull up the student investigation sheet. Remember, to find your student investigation sheet, click your assignment for Lesson 2, Investigation A Workshop, and you'll see the student investigation sheet right there in the middle. You guys would? Click it, and let's fill out some of the thoughts you had in your science notebook. Imagine that car again. If I push the car, what forces apply to the car when it's at rest before I push it? Make a list of all the forces you think are on that car when it's just sitting on the desk. The second, what forces are applied to the car to make it move? So if I wanted to move my car forward, what forces would be on the car to make it move forward? Now, after I started moving and it's rolling, what causes the car to slow down? What force do you think that is? Write that in the third column for me. We're not going to do the fourth column because, again, we're having trouble measuring. We're going to take some measurements in the investigation. But imagine what we can fill down that fourth column is the idea of, what if I pushed it harder? What do you think would happen to the distance the car rolled? What if I pushed it softer? Write your answer to those two questions in that fourth column for me. And then the fifth column, why do you think the car slows down and ultimately stops? What force do you think causes the car to slow down and stop? Fill out your answer to that in the fifth column. Now let's have a classroom discussion about the answers to each one of these. That was an excellent classroom discussion. Thank you for participating. Let's review what we discussed. Each one of us identified forces in the situation. We described whether or not they were balanced or unbalanced. How could we tell again how they were balanced or unbalanced forces? Balanced forces mean the object's motion does not change. We use the example of the car in my hand. It's still not moving, correct? Which means the forces are balanced. There's no change in its motion. If the car was traveling at a constant speed like this, that means all the forces are balanced. There's no change. And we look for change in speeding up, slowing down, or changing its direction. Unbalanced forces, however, cause an object to speed up, slow down, or change direction. And that's where we discussed, what if I pushed the object up? That push, or as the object fell, gravity made it go faster. Those are examples of unbalanced forces. And you also identified the heavier the object is, the harder it is to push or pull on it, to get it to change its motion. And that's where we got introduced to the word inertia. Inertia is an object's resistance to a change in its motion. Objects, once they're stopped, they want to stay stopped. Once they start moving, they want to keep moving. We discussed that that's how you realize that when we were running. That once you started running, you were able to keep running fast, 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 fast. But it was hard to slow down. It was hard to get running because that's your inertia. Once you're at rest, you want to stay stopped. Once you're moving, you want to keep moving. We discussed all those examples of inertia, and the more mass you have, the heavier you are, the more inertia you have. Now, how can we continue this discussion and actually examine the role of forces and unbalanced forces on objects? How many of you know what a spring scale is? Some of you guys know what a spring scale is. I'm going to share my desktop with you in the demonstration video. You can see the demonstration video on your desktop, or you can follow along with mine. So I'm going to show you what a spring scale looks like. As you can see right here, this is what a spring scale looks like. There's a spring in the center cylinder right there, and it measures force. And so if we click play on our video, You can see the gentleman here is pulling down on it. The harder he pulls down on it, the further the spring compresses, showing more force. It's a way of simply measuring force. That's what a spring scale does. So what I'd like you guys to do right now is, let's run a simulation and see how a spring scale works. So if you guys would, please go back to your assignment and let's click on the spring scale simulation. It's on the right. See where it says spring scale with the play icon. So let's click that play icon and pull up our spring scale. And we can adjust the mass that's on the spring scale. And watch, the spring scale's measuring how much force. So with 2 blocks, it took 1 Newton's worth of force. You guys take a second and play with it and see if you can find that idea of inertia in this simulation. The more blocks you have on the screen, what do you think that means about the force you have to pull with? How about the fewer blocks? What do you think that means about the force? Take a second, jot down your observations in your science notebook, because we're going to have a classroom discussion about it in a second. Okay guys, that was a really good discussion. You're exactly right. The more mass or the more inertia an object had, the harder it was to pull. So for example, we have the spring scale right now with 4 blocks on it. Let's click play and let's see how hard it is to pull. 4 blocks took us 2 Newtons to pull it. What if we reduced it down to 1 block? And the spring scale is measuring the force. It took only 1/2 Newton. Spring scales allow us to measure the force. The further the spring scale stretches, the more force that's present. Does everybody understand that? Excellent, because that's going to be real important, because in a second we're going to actually apply forces to a car and we're going to see what happens. Now that we know how a spring scale works, let's use the spring scale to measure how force changes an object's motion, how an unbalanced force can cause an object to speed up, slow down, or change direction. We're going to use the spring scale to hit a car and we're going to measure how far that car rolls. So start thinking about that. In order to do this investigation, we need to do part B of your student investigation sheet. So if everybody would go to Carolina Science Online and make sure you click on part B of the student investigation sheet. Now we're on part B of the student investigation sheet, and we're going to use the spring scale to hit a car with 0.5 Newtons worth of force and then 1 Newton's worth of force. We're going to repeat 2 trials for each of the forces. Remember, we talked about what a trial is. The same experiment done more than once. That's a trial. And so on each trial, we're going to answer the following 5 things. First, we're going to describe the forces that are acting on the car when it's at rest. We're going to describe the forces applied to the car that makes it move. The forces applied as the car moves, meaning while it's in motion. We're going to measure the distance the car rolled with each force for each trial. And then we're going to describe the force causing the car to stop. And so as we observe the experiment, we want to keep in mind what are the observations that we need to make and what data do we need to collect. Now, you guys can follow along on the demonstration video on your own device, or you can watch the demonstration video from my desktop. Take a second, decide how you want to do it, and I'm going to show the demonstration video on my desktop. Okay guys, are you ready? Here comes trial 1 and 2 with 0.5 Newtons worth of force. Make sure you make good observations. I'm going to pause for just a second. Think about what you just saw. The car rolled and stopped. Give you guys a few moments now to record your data. We'll do the distance as the very last thing, so leave the distance column blank. Now that everyone's gotten their data recorded, let's watch trial 2. Again, the same amount of force. What do you think is going to happen? Make good observations. What can you already tell about the distance? That's right. Looks like it rolled very similar distances. Well, let's check. There's trial 1 from above. Let's zoom in and see what that distance is. Now, everyone practice your skill of reading a meter stick. How far did the car roll? Record that in your distance. I'm going to zoom back out. And now let's watch trial 2 from above. Let's zoom in. How far did the car roll this time? How do the 2 trials compare? How does this match with your prediction from earlier about how hard you hit the car with the force, how far the car will roll? Zoom back out, and now let's watch the 2 trials. Now let's watch the 2 trials for 1 Newton of force. What do you think is going to happen? Wow! Was that what you would have expected? Now let's watch trial 2. Take a moment, fill out your data table for trial 1 and 2 with 1 Newton of force. Is that what you have predicted? Now, let's measure the distance of trial 1 and trial 2. Let's zoom in. How far did it roll with 1 Newton of force? Now I'm going to zoom back out so we can see trial 2. Let's see what happens with trial 2. Let's see what happens with trial 2. There's trial 2. Let's zoom in and see how far it rolled. Let's record our data for trial number 2 and have a classroom discussion about our observations. Now we've completed the investigation, let's apply what we've learned. In your assignment, scroll to the very last item, the Tell Me More. Take a moment, click on the Tell Me More, and answer this question for me. Do you think you need a larger or a smaller force to move an object further? Explain your answer with either words or a drawing. After you complete your Tell Me More, please update your 2-column chart we started at the beginning of this unit with the ideas that we talked about today. During the literacy time, we're going to read the book Gravity is a Mystery, and we're going to discuss inertia and gravity. Thank you. I hope you guys have a good day. I hope you enjoyed that model lesson. We started this workshop by developing a lesson plan incorporating the 8 strategies for distance learning from Next Gen Science. The second part of the workshop was a modeled lesson based on these 8 strategies. I hope you saw all 8 strategies being used. If you're looking for additional strategies and resources for your distance learning classroom, one of the best websites I can recommend is the Get Ready Professional Learning website from Carolina. At this website, you can find resources and strategies on incorporating breakout rooms into your classroom or leading a classroom discussion in a virtual environment, getting assessment back from your students. This website is really useful for teachers who are also currently using the Building Blocks of Science 3D or teachers who are considering using Building Blocks of Science 3D. I I really appreciate your time this afternoon. Thanks for watching the workshop, and I hope you got something out of it in using these 8 strategies in your distance learning classroom. Thank you.